Hi, hello, welcome to my channel Excel Max and Board. Now in this video we'll see how to apply the properties of determinants and proceed with the important sums. Now these are the formulas. If A is non-singular, already we have defined what is a singular and non-singular matrix in the previous video. So all these formulas need to be taken care of so that while calculating, while doing the sums, it will be useful. And this one, AB the whole inverse is B inverse A inverse. And these are some of the important formulas which you need to memorize so that if any 1 mark question, MCQ question is asked, you will be able to give the answer immediately without much time, right? So please make a note of all these formulas. And a square matrix is said to be orthogonal if A into A transpose or A transpose into A gives you the identity matrix. That is one another formula, determinant Ka equal to K power n into determinant A. So these are the important formulas and properties pertaining to determinants which will be asked in MCQs, right? Now we'll proceed with some of the important concept oriented sums, right? Now find the inverse of a 2 by 2 matrix. In the previous video we saw the inverse of a 3 by 3 matrix. Now we'll do inverse of a 2 by 2 matrix, right? Now what is inverse? Now let me name this matrix as A matrix, okay? So what is inverse formula which we have done in the previous? So A inverse is 1 by determinant A into adjoint A. This is the formula. So let me find what is determinant A. Determinant A is 5 ones are 5. So minus 1 twos are 4. So 5 minus 4 is 1. So it is 1 by 1 into adjoint. Now how to calculate adjoint of a 2 by 2 matrix? Adjoint of a 2 by 2 matrix is done by swapping the main elements of the main diagonal. By swapping the elements of the main diagonal. So main diagonal, what elements are present? 5, 1, 1. Just swap it. So it becomes 1, 5. So I have swapped the main diagonal and changed the sign of the elements in the other diagonal. So now here it is plus 4. Change the sign. So it becomes minus 4. Here you should not swap. You should only change. And this also plus 1 becomes minus 1. So this is the inverse of a 2 by 2 matrix. So 1 by 1 is 1. So the final answer is 1 minus 4 minus 1 and 5. This is how you should find the inverse of a 2 by 2 matrix. Now let me proceed with the second sum. Solve the matrix equation 5, 4, 1, 1 into X matrix is equal to 1 minus 2, 1, 3. That is, you have to find what is this X matrix. If we don't know determinant, obviously we'll take what is X. We'll find the order of the X matrix, then we'll proceed with matrix multiplication and do it. Now since we have learned what is determinant, let me name this matrix as A. This matrix is already given as X and this is B matrix, right? So this is A, X is equal to B, that is what is given as. Now Ax is equal to B, I need to find what is X. So X is equal to A goes this side as A inverse, that is multiplying by A inverse on both sides. I get X matrix is equal to A inverse into B. So I need not do the sum using matrix multiplication which takes time. So X is equal to A inverse B. So let us now proceed how to find A inverse for a 2 by 2 matrix. So X is equal to, what is A inverse? 1 by determinant A. That is, just now we have done that. So it is 1 by determinant A into adjoint A. The same sum only I have given it here. So I have found A inverse already. So it is 1 minus 4 minus 1 and 5 A inverse into B matrix. What is B matrix? 1 minus 2 1 and 3. So now this is matrix multiplication. This order is 2 by 2 and this matrix is also of order 2 by 2. So the resultant matrix also will be of 2 by 2 matrix. Matrix multiplication has already been done in operation of matrices. Those who have not gone through that video, please go and learn how to do matrix multiplication. So if I proceed, so what is the answer we get here? I'll give you some 2 minutes time, work out and let me know the answer. So it is 1 minus 4. So this is minus 3. Minus 2 minus 12 is minus 14. Minus 1 and 5 So this is 4 and minus 2, sorry, plus 2 plus 59, this is 17. Solve for X matrix. So I have done using determinant method instead of doing using matrix multiplication. So this is little bit less time consuming, so we can go with this. இல்லனா matrix multiplication பண்ண மாதிரி let X matrix is equal to A, B, C, D. 2 by 2 matrix எடுத்து we have to multiply and then equate each and every corresponding element, get a pair of linear equation and solve it, right? So this will be easier once we know what is determinant. Now we'll move on to the next sum. Show that the matrix A satisfies this equation. Hence find A inverse. Please look at the word hence find A inverse. Means already you have to verify this. Then you should make use of this to find what is A inverse. Okay. So let us try to solve it or verify it. Proof. What is A matrix given as? A matrix is given as 6, 5, 7, 6. Now he is asking satisfies this equation. So I should prove A square minus 12A plus I matrix is equal to 0. I know what is identity matrix. Since this is that, we'll see A square minus subtraction and it is plus I matrix. So addition and subtraction can be done only if and only if the order of the matrix is the same. So here I matrix is of order 2. Now this is A square. Show that it satisfies. Okay. So let me compute what is A square. What is A square? A square is nothing but A into A matrix, which is 6, 5, 7, 6 into 6, 5, 7, 6. So if I multiply using matrix multiplication, I get the following result. So this is the result I have got after multiplying A into A. It is 71 2 by 2 matrix. Now I want minus 12A matrix. So minus 12A is, that is minus 12 is multiplied to each and every element of A. So 12 into minus 6 is minus 72. 12 into minus 5 is minus 60. 12 into minus 7 is minus 84. 12 into minus 6 is again minus 72. Now I know what is I matrix. I matrix is 1 0 is 0 1. So I have individually found what is A square, what is negative 12A and what is I. Now I need to add all. Therefore it is A square minus 12A plus I matrix is equal to, I should get a 0 matrix, right? So it is A square, that is 71, 60, 84, 71 minus 12A matrix. Since I have taken that minus 12 inside, I am putting it my plus sign here. Minus 72, minus 60, minus 84 and minus 72 plus I matrix. Plus I matrix is 1 0 0 1. Since it is matrix addition of we should add the corresponding elements in the respective places, which I get it as 71 minus 72 plus 1, which is 0. 60 minus 60 plus 0 is 0. 84 minus 84 plus 0 again 0. 71 minus 72 plus 1. So this is a 0 matrix. This is what he has asked me to prove. Show that it is 0. I have got hence proved, right? Hence proved. Okay, now I have found that this A matrix satisfies this. Okay, hence find A inverse means using this result you should find what is A inverse. Shall we now consider A square minus 12A plus I equal to 0 matrix, right? Now multiplying by, who is multiplying by or pre-multiplying by A inverse, I get A square into A inverse minus 12a into A inverse plus I into A inverse equal to 0 into A inverse, right? When the bases are same, obviously you can add up the powers. So this becomes A square into A power negative 1 is A minus 12. A into A inverse is nothing but I matrix plus identity matrix multiplied to any matrix will give you the matrix which is multiplied. Okay, now I have got A inverse here. Now we have to find what is A inverse. So A inverse is 12i minus A. I am just transposing this to that side. A inverse is 12i minus A. So I can compute 12i is nothing but 12 0 0 12, right? So this is 12i minus what is A matrix given as in this sum. It is 6 5 7 6. So it is 6 5 7 6 in a matrix subtraction. So corresponding elements can be subtracted. So it is 12 minus 6 6 0 minus 5 is minus 5 0 minus 7 is my negative 7 12 minus 6 is 6. Okay, this is how you should proceed with hence find. Again you should not compute A inverse using formula. You should compute using this equation what he has given. That is the meaning of hence find. If you want, you can cross verify. What is A inverse of a 2 by 2 matrix? Swap the elements along the main row and change the sign. And the determinant value of this is 36 minus 35 is 1. Hence, you can verify, but you cannot find A inverse using formula because in the question it is given. Hence, find. So, please make a note of it. Now, let us proceed to the next sum. Find A inverse. Hence, solve the linear equation. Again, here also it is hence solve. Normally, how we will solve? We will write the equation in matrix form and then we will solve using determinant method, right? So, now let us compute what is A inverse. What is A inverse formula here? A inverse is 1 by determinant A into adjoint A. Now, let us find what is determinant A and adjoint A. So now let us find what is determinant A. Determinant A also has been explained in the previous video. So it is 1 into 1 plus 3, 4 minus 2 into minus 1 plus 2 plus 5 into the element multiplied by its cofactor, right? So 3 plus 2. So if I simplify this, I get it as 27. So this is determinant A. Now let us go for cofactor matrix Aij. Cofactor matrix also has been explained in the previous video. So let us just copy it. 1, 2, 5, 1, 2. 1, negative 1, negative 1, 1, negative 1. 2, 3, negative 1, 2, 3. Then it is 1, 2, 5, 1, 2. Then it is 1, negative 1, negative 1, 1, negative 1. Right? Then just strike off the first row and first column. Eliminate the first row and the first column. You may not consider that. Which is equal to. So if I find the answer, I get Aij as 4, negative 1, 5, 17, negative 11, 1, 3, 6, negative 3. Found Aij. Now we'll go to A inverse. A inverse is AIG transpose. So A inverse is 1 by determinant. Determinant A I've got as 27 into adjoint A. Adjoint is 4, 17, 3, -1, -11 is 6, 5, 1, -3. So now I found A inverse. Find A inverse I have found. Now I have to hence solve the system of equation. Okay. Now let us try to solve this system. Before solving the system, we should put it in matrix form, right? So let us put the given equation in matrix form. So it becomes 1, 2, 5. Next 1 minus 1, that is x coefficient, y coefficient and z coefficient. Third equation 2, 3 and -1. So, okay. 2, 3, -1 into x, y, z is the constant matrix, that is 10, -2 and -11. 10, -2, -11, right? Now just consider, look at the matrix 1, 2, 5, this matrix and the given question. It is the same. So the A matrix only is given in this equation. So I can write this is A matrix, this is X matrix, and this I'm considering it as B matrix. Now I need to find the values of X, Y, Z. So X is equal to A inverse B. This is how we proceed. Hence find, already we know what is A inverse, we have found already here. So now just we need to substitute and get the answer for X matrix. Okay. So X matrix is nothing but 1 by 27 into what is A inverse? 4, 17, 3, -1, -11, 6, 5, 1, -3. This is A inverse into B matrix. B matrix is 10, -2, -11. So we need to do matrix multiplication. Consider the order. This is 3 by 3 and this is 3 rows and 1 column. So the resultant will be a 3 by 1 matrix, right? So it is 1 by 27. Multiply and get the matrix. So you get it as -27, -54 and 81. Now this every element is divisible by 27. So if I take this 27 inside and divide every element, I get -1, -2 and 3. So hence solve. Therefore x is equal to -1, y is also equal to -1, z is equal to 3. I didn't find A inverse again because this question, the coefficient of x, y, z in each equation, you just verify the coefficient of x, y, z in each equation and the given A matrix are the same. So here see 1, 2 and 5. 1, 2, 5. 1, -1, -1. 2, 3, -1. That is why I'll ask you hence solve it. Okay. So you should not find again and again A inverse. That is what he means to say. But normally children used to find A inverse again here and waste the time. And they didn't understand the question. Hence fine. So you do not get full mark also for this. Right. Now we'll move on to the next sum. Find A matrix and B matrix is given. How to find A B matrix? Hence solve again. Hence solve the system of equation. So as we have already seen how to find hence solve. Now we'll just compare this equation and which matrix are same. 1, -2. Only you have to consider the coefficient of x, y, and z. Don't bother about the constant. So it is 1, -2. Here 2, 1, 3. And it is 0. X coefficient is 0, -2 and 1. So this equation, coefficient of equation is the A matrix, right? So that is the hint. First we have to check it is A matrix. So how now if I write this equation, I'm just giving you the shortcut. If I write this in matrix form, I get x A x equal to B. So x is A inverse B, correct? Now let us find what is AB matrix. Because he'll ask me to find what is AB matrix. A B matrix. A matrix is 1, negative 2, 0, 2, 1, 3, 0, negative 2, 1 into B matrix. B matrix is 7, 2, negative 6, minus 2, 1, 3 and negative 4, 2 and 5. So this is B matrix. So if I multiply, what answer I should get? Multiply and let me get the answer. So if I multiply, I have changed this number as negative 3. If I multiply AB matrix, I get it as 11, 0, 0, 0, 11, 0, 0, 0, 11. Okay. So that is AB matrix. AB matrix is equal to 11 into I matrix. That is what I have got. Find AB matrix. Now the given system is, keep it aside, we'll come and solve it again. Now the given system is written as X matrix, that is 1, negative 2, 0, 2, 1, 3, okay, consider the equation and put it in matrix form. So it becomes 1, 2, 0, 2, 1, 3, 0, negative 2, 1 into X matrix. X, Y, Z is equal to the constant matrix 10, 8 and 7. That is what I have, 10, 8 and 7. Now let me, this matrix is the A matrix which is given. So I am naming it as A matrix. A matrix and this is X matrix. I am taking this matrix as C because already there is one matrix in the question itself as B. Now I need what is X matrix. What is X matrix? X matrix is A inverse into C. Now I should find what is A inverse. Question hence find. So I have to make use of this. Now I can write multiplying this equation by B inverse on both sides. Suppose multiplying by B inverse on both sides. What do I get here? So A, B. What I need? I need A inverse. A, B inverse is equal to 11I B inverse. Now pre-multiplying by A inverse on both sides, I get A inverse A B equal to 11 A inverse I. Now this A inverse A is I matrix, correct? So I into B matrix is B matrix is 11. A inverse into I matrix is A inverse. So I can write B matrix by 11 is nothing but A inverse. Fine. Now let me go and substitute this A inverse here. So this becomes what is by 11? So 1 by 11 into what is B matrix? B matrix is 7, negative 2, negative 6. So just copy 7, 2, negative 6, negative 2, 1, negative 3, negative 4, 2, 5. So this is B matrix. So A inverse I have done B matrix by 11 into C matrix. What is C matrix? 10, 8, 7. If I multiply, I'll get 1 by 11 into 44, negative 33, and 11. Each element is divisible by 11, so I get it as 4, negative 3, and 1. So x is equal to 4, y is equal to negative 3, z is equal to 1 is the solution for this given matrix. Okay, so this is a hence find. So you have to make use of this and find the answer. Now how to get this answer without multiplying this? Just check what is, now I want A inverse, right? Now just check what is determinant A here. If I calculate determinant A, I'll get it as 11. Okay, wow. So invariably we can write it as it is a 11 into I matrix. Multiply only we can write the using shortcuts. So you no need to multiply one. Just find determinant A, and if I multiply AB matrix, it will be determinant A into I matrix. It will not consume much of your time. Otherwise, to find A inverse using this, and then substitute this A inverse. A inverse is B matrix by 11 into C to get the answer. Is it clear? Hope this video will help you in finding the solutions for some different type of questions in determinant. See you in the next video, guys. Bye.